How we doing? Thank you guys for sticking with this. You know, it's a gorgeous day outside. This does not exactly, I'm from New York, and I've heard all these rumors about Seattle weather, and it is sunny out there. It didn't start that way today, right? Did you guys see the fog this morning? I figured it out. The Seattle Hemp Fest is 200 yards to the north, and I think that was the source of it, purely meteorological, I'm sure. Actually, I took a run through there, and I noticed that all of the stands, like about 80% of them, were snacks, you know, just in case the attendees were, I don't know, hungry. So anyway, all right, I didn't come here to talk about the Hemp Fest, although I would like to. We're all here to talk about what's possible with this sort of class of post-PC devices. Man, we've seen a lot of pretty cool things so far. And to look at, what's possible right now. And I thought that actually it would be interesting to actually take a little bit of a break and look into the future, into the very near future of what's approaching, of what this new class of devices is allowing and making possible, but maybe we aren't quite yet taking advantage of. And so friends, if you're ready, I'd like to propose an expedition. Could use some audio too here if we've got it. An expedition into, into the hazy edges of the technology universe, where we're going to be able to see what's coming soon and coming really quickly, so that we can understand what's on the way and prepare now for that and start to actually implement some of this stuff. And so what I'd like to do in our little expedition into the future is to really sort of start with where we are right now. And if you think about what it is that makes this sort of new class of devices special, unusual, I'd say that the big shift that's introduced for phones and for tablets is sensors. It's not just that these things are always with us, or that they're lightweight, or that they're so inexpensive. That's all part of it. But it's that these things are loaded with these superpowers, right? I mean, look at what these things can do. They've got camera and microphone and touch, light detector, proximity detector, accelerometer, GPS, of course, a compass, a gyroscope, for crying out loud. A lot of people approach mobile and start off by saying, well, it should be the companion experience to the real desktop experience. And friends, that's the wrong question. It's not how do we do less on these devices. It's how do we do more, right? Because phones and tablets, these things can do more than the traditional computer. So the question is, man, how do we start really pushing the limits of that? And, when we've begun to see some interesting experiments with that, right? The first phase of this, I would say, has been kind of marked by, particularly around GPS stuff, location. When's the next train from the location closest to me leaving? And that's super useful. But, I would say that sort of the next generation of stuff, as we push the boundaries of what we can do with sensors, is less about asking, what's nearby, what's around me, but sometimes making sense of what's directly in front of me. And so, and we've seen some of that stuff, right? I mean, stuff like Shazam. Remember the first time you saw that? Right? Wow, this thing is like paying attention to what's going on around me and is a lot smarter than I am, at least in terms of sort of musical knowledge. So if we use sensors like that to parse and interpret and make smart inferences about our immediate environment, that's pretty cool. That's a starting point. And of course, we've also seen some experimentation in what I would say is sort of the next phase of pushing that forward, the opportunity to actually transform reality, right? I mean, that's the idea behind augmented reality, to add new layers of understanding and insight beyond what our puny eyes and ears can detect on our own. I'm sure you guys have had this experience, right? Where it's sort of the sense that augmented reality is a little bit of a solution looking for a problem, right? Where it's like, wow, that's kind of cool, but actually I would never really use that. So I think one of the things is just a period of experimentation of figuring out how do we use this stuff? How do we use the camera vision on board tablets, on board phones, in compelling ways to use augmented reality? And I see a few examples of that where it is, in fact, useful and fun. And the first, frankly, as with just about all kinds of experimentation, begins with games and toys. And we saw in Curtis's talk with the dice, right, that sort of the toys are often great places where we experiment and really see new kinds of interactions. We'll see some examples of that in a bit too, some other hardware examples. But first, to look at an augmented reality example of a game, Skinvaders is a game that uses the front-facing camera to turn your face your face into a game board where, aliens are invading your skin. Let's sort of take a look at what this looks like. Whoops. Let's take a look at what this looks like. So first you start off by scanning your face, so it kind of gets a bead on what the lay of the land is. It's like, oh, she won, but she still wound up with an alien in her brain. And you see this stuff, especially, kids love this thing. It's like, wow, how whimsical is that? It's imposing this weird sort of pseudo-reality onto what the stuff is around me. You're like, wow, if that's the possibility, sort of making pretend that this is happening in my actual environment, what else is possible? IKEA is pretty interested in this. If the idea of the game was to introduce whimsical kind of what-if objects into your environment, IKEA doubled down last week by introducing this whimsical kind of what-if furniture, where you scan stuff that you like, you see it in the catalog, and then you drop the catalog into your home where you want to see the thing. That's its sort of anchor, that's its cue. And then, man, the thing just sort of teleports right into the view. So you can check out, does the furniture fit? How does it look? What's it like? So this is sort of the useful thing. It's not, whoa, where's the nearest Starbucks? So it's 8 miles away that way, which is sort of where we started with augmented reality. It's really literally, how do we augment reality, right? And part of that, frankly, that's sort of a nifty thing, but there are also sort of simpler uses that really get down to the nub of how can I actually use things like augmented reality and camera vision to speed input, sort of make my life easier as a user. WordLens is an app that came out, I guess a little bit over a year ago. And the idea is that you take your camera and you point it at text in another language. And then in real time, in here, it changes it into English or some other language, right? And so when you're traveling, you can use it on the menu so that, man, you're not going to order the tongue again by accident, or the tripe, right? Or maybe some other potentially embarrassing situations can be avoided. And you think about this, it's a pretty nifty trick. And really, at its base, though, it's just old school OCR, optical character recognition, right? The magic here is just that it happens to be doing that sort of font replacement, using a similar font and a similar color. That's kind of the interface magic. But at its root, it's using the onboard sensors, the camera, to save me input. Because really, I could just do this by typing it into Google Translate, right? So how do we think about moving the interface off of the screen so I don't have to tap away at the screen and into my environment? That's the opportunity of designing for sensors and not just for screens. Let's give you an example of that too. We tend to think about augmented reality as being a visual thing. Some friends in Sweden who came up with this app called Table Drum, and they call it augmented audio. Table Drum is basically a drum kit app. There's lots of these things in the app stores. We sort of tap away at the screen, choose an instrument, and it makes a rhythm. Great, it can do that. But its special magic is it actually uses the microphone to listen in on you tapping on your table, and then it makes your table essentially into this drum set. So let's see how it looks. What's going on is it's just sort of like paying attention to what's going on the taps and thumps on the table. And while all the logic is happening in the phone, it's really just a speaker now, right? Oh, doesn't know that sound. So let's teach it. We'll choose an instrument, a cymbal, and then we'll put it into training mode. Oh, that's the sound that we're going to teach it. Nice. But see, what's happening here, right, is that's kind of cool and pleasant. But really the most interesting thing about it is that by using these sensors, the interface is moved off of the screen entirely. It's no longer about being on your screen. And if you think about what's happening right now with screens, as powerful as all these little glowing rectangles are in our lives, they're kind of overpowering us, right? We have all of this antisocial behavior built around me looking at my screen all the time, interacting with my screen. And while touch interfaces are things I'm really excited about, it's not the only interface that's out there, right? How can we design for sensors, all these powerful sensors that are in these devices, so that we can move the interaction off the screen and we can have a more just natural social experience in the world around us, with the people around us and also with the objects around us. So I've been really sort of consumed with working with touchscreens, really particularly since the iPhone came out. That's how I've been spending the last few years of my life. But what I've come to realize is that sometimes the best touch interface, sometimes no touch at all, right? Because we're clumsy with our fingers, and the screens are clumsy and inaccurate and slow. So how can we move things off the screen? And we're starting to see, right, other types of input. Touch became mature first, but speech is coming on strong. It doesn't work totally well yet, right? Any of this sort of speech recognition isn't exactly great yet. Apple, I think, still calls Siri beta, and it feels like it. We've got Connect and Leap Motion, these sort of natural gesture, and wow, that seems super promising too. You can see it's just about mature. Again, you wouldn't want to run a nuclear power plant with this stuff yet. But it's like, wow, it's almost there. And so how can we sort of think about using this thing, including, camera vision and facial recognition, really frankly, all these ways that we communicate with one another as human beings, touch and speech and facial recognition and natural gesture. The machines are beginning to learn how to do it in these crude ways. And now it's up to us as designers and developers to understand that stuff. And frankly, not just in isolation. We tend to think of this over here as a keyboard interface and a mouse interface, and over here a touch interface, and speech, and gesture. Friends, the future is about combining those things into interesting ways. And I'll touch on that in a minute with some examples of what that means and how powerful and frankly magical it can be. Still though, it's like I promised a little bit of a journey into the future, and we're still sort of exploring where we are right now. And just one other term that I want to show that is I've been trying to make a case that, wow, actually the sensors that we have on board our phones and tablets right now are already really powerful to create entirely new kinds of interaction. But what if we start adding custom sensors? We're starting to see, we heard about Square earlier this afternoon. I mean, that's a pretty interesting custom sensor, right? You plug it into your phone and boom, it can read credit cards. Sort of what else is up there? That stuff starts to get really interesting when suddenly the devices we use every day can talk to any arbitrary object. Medical and healthcare industry, really interesting here. They've always been great at making sensors and terrible at making interfaces for them, right? And they've realized in the last few years, wait a second, tons of our customers now already have computers with them with great interfaces. So how can we plug our sensors into those? Here's one pretty trippy example. It's in testing right now. It's about to be approved, if all goes well, by the FDA. It's a company called Proteus that makes a pill that detects when it's been taken. It's got this little sensor that's about the size of a grain of sand. Same stuff that would be in like a vitamin, right? Like magnesium and copper, totally harmless stuff. But you can put it in a pill, and when you swallow it, your stomach acid activates it like a battery, and it sends us a very weak signal with the serial number of the pill. You wear a little patch that has Bluetooth on it. So it catches the signal and sends it to your phone or tablet, relays that to the information. Your doctor says, oh, you've taken the pill, good for you. We've got tons and tons of these sort of examples like this. But one of the things that's important to realize is it has become so trivially inexpensive to put a sensor and an internet connection on just about anything that you can swallow it and your body does whatever it normally does with such things. It's disposable technology. It's so cheap that we can make these trivially interesting improvements, incremental improvements to our experiences every day. It's like, wow, you think about this stuff, wow, a pill that knows it's been taken, other things that just know things about what's happening with your body and can relay that to the internet. And it starts to get to be some pretty trippy Star Trek tricorder stuff, right? Now, to sort of turn from a little bit of the sublime to the ridiculous here, you can really hook up just about anything to a digital experience now. Here's one literally Mickey Mouse example that the researchers at Disney Research came up with. Something that they call Botanicus interacticus.
Botanicus interacticus is a new interactive plant technology. It requires no plant instrumentation. A simple electrode placed in the soil turns any plant into an expressive, multi-touch, gesture-sensitive controller.
Oh yeah, Plant UI, you guys. You've been waiting for it. Oh, that's good. Yeah, right there. Oh, that's good. That's good. Now, look, I have no idea why Disney made this thing, right? I don't know. The parks, maybe? I don't know. But the point is that, wow, you can make anything talk to a digital experience now, or even control it, right? I mean, here a plant has essentially become a joystick for this experience, right? So this can get even crazier. I mean, wow, you can hook up anything to computers now. You can hook up cows. The Swiss, of course, came up with this thing with a sensor that goes inside the cow, and detects when the cow is in heat. And then the cow texts the farmer. Texting when you're in heat. I have a lot of friends who do that too, right? And because it's Switzerland, you know, the text can go out in Italian or French or German, you know, because cow love knows no language boundaries. So we have this internet of bovines that's happening here, right? Now, so my point here is not that it's like, wow, great, we can, you know, have cows and plants, you know, as our interfaces. The point is anything can be an interface now. So I think in the last few years, we've been consumed with this idea: how can we make our digital interfaces, how can we etch those onto these physical slabs that we take out into the world and make the digital experience more physical? At the same time, what's finally beginning to happen after years and years of sort of prediction about this, is that the physical world is becoming digital. We're able to put sensors and controls and internet connectivity on the mundane objects, animals and plants, in the world around us. And you know, wow, that's a really interesting confluence of places to work in. So I would say that the big marker of where we are now are these personal sensors. But your device is not only a sensor for input, but a broadcaster. So if we embark on our mission with a quick hop, we get to mirroring. And for the most part, that simply means screen sharing. That's the whole idea, of course, behind AirPlay and similar technologies. This idea that you can mirror your screen via Apple TV to your television set to share photos and videos. And that begins to make it social, not just with other people, but with other devices. Ultimately with other people, of course, but what I want to focus on is this idea of social devices, where your phone or your tablet is not just a sensor, but this broadcaster that can broadcast content to otherwise dumb devices, and so somehow give them the illusion that they've got some smarts. Becomes the sensor and receiver for those dumb devices, like a TV, which we've been hearing a lot about this afternoon, right? How do we kind of get familiar interfaces onto TV? Yeah, it was great to see the Samsung Watch On example earlier today. I think that that Samsung, like a lot of companies, until very recently, was sort of saying, well, how can we answer this sort of smart TV problem? Well, it's literally, let's go ahead and make a smart TV. So instead of mirroring, of having one smart device broadcast to a TV, the idea is let's make every device smart and give them these independent operating systems. Who needs to mirror, they say, when everything can be a smart device? So you have things like the Samsung Smart TV.
Hi, TV. Smart Hub. See that? This TV actually recognizes my voice and pulls up the Samsung Smart Hub, giving me instant access to my favorite apps like ESPN ScoreCenter.
Kind of hate that guy. You guys know what I'm talking about, right? I kind of hate that guy. And more important, I'm not really crazy about his TV, because the reason is it's got this whole operating system, its whole sort of conventions that are unique to its own, so every time I have to watch a TV, I have to learn that one thing. But you know, this idea of making everything smart is an idea that futurists have been sort of taken with for quite some time, particularly in the kitchen. Wow, smart refrigerator for some reason. People are really kind of enthralled by that. At CES, Samsung, in fact, came out with a smart TV. Did you guys hear about this? The Evernote-compatible, refrigerator. The Evernote-compatible refrigerator, like it uploads content to your Evernote account? All right, sure. There's this idea that for things to be smart, they all have to turn into web browsers, or they all have to turn into Twitter clients. I would suggest that actually the better way to think about connecting the mundane objects in our life is to sort of make mundane improvements. Not how do I turn the refrigerator into an entirely different thing, but how do I make it a better refrigerator? Microwave ovens. I don't know about you guys. I use my microwave oven pretty much mostly as a clock. It's like a clock that incidentally has an oven on it, right? What would be a better way to make it a better microwave if I added an internet connection? Not to make it so I can browse the web from my microwave. I just want the clock to be right? Mundane improvements to the mundane objects in our lives. Let's think about, you know, internet connectivity to just making it a better product in one way or another. So I think that sort of this future, this idea of making things, of giving everything smarts, of giving everything an operating system, is a little bit of a non-starter, not least because I've already got too many operating systems in my life, right? And every time I have to learn one, so I have to learn all these new conventions and try to remember which one is which. So how do I get from this situation to this sort of more Zen-like period of, sort of peace and calm? Well, I think that one way to do it, I think that we've seen a lot of sort of glimpses of this throughout, of sort of a lot of companies, a lot of designers, a lot of developers trying to sort of figure this out. I think the one answer to that, as we sort of push out again into our little mission here, is that part of maintaining sanity is frankly limiting the number of smart interfaces we have to deal with. We just heard about this really interesting idea of, well, let's create, I guess it was a Samsung Watch On demo. It's like, let's create, and I think that the last presentation about tablet as TV also is pretty compelling in this. Let's create one single software interface for all these different points of interaction. So if we hop out from mirroring to this sort of idea of remote control, where we have a handful of smart devices, like our tablets, that can drive and control all the dumb devices in our lives. There are sort of surprisingly few, things like AirPlay, for example, is one thing that where we can see that. Any AirPlay developers here for iOS? No, all right. So this is actually an interesting opportunity to sort of use this technology, and other platforms have something similar. But it can be more than just mirroring. You can also have these sort of completely second screen experiences. So in this game, we've actually got the iPad that's flying your plane on the TV. And this is beyond mirroring, obviously. This is a generic device acting like a purpose-built controller or remote that's working on the dumb device, like the TV. Now, of course, this is using Apple's sort of proprietary system with Apple TV. Microsoft likewise has smart glass to control your Xbox or get secondary, sort of second screen content on your phone or your tablet, whatever platform you might use, it can work with that. Of course, this little guy came out earlier this month, Chromecast. It plugs into your TV so that when you're watching video on one device, or in your Chrome browser, for example, you can tap a button and push the video over to the TV. It feels like mirroring. What's actually happening behind the scenes is it's actually going off and fetching the content independently from the web. So it's actually remote control. So that's pretty much the state of the system as we know it right now. This is where the mainstream technology is pushing at the frontier. In all these cases, though, sort of jumped the gun. In all these cases, though, there's a single smart device that's controlling the display. Either its own display or a remote display on a dumb device. Broadcast, right? But let's push that and go a little further out in our expedition. And frankly, here's where things get interesting. An important element of the near future, I think, is more ambiguous control, shared control between smart devices, where the primary control shifts from one gadget to another depending on your context. Contextual computing, I believe, is what Curtis called it in the stuff that Samsung is working on. We know the concept already, I think, from the good old the good old car phone. So say you're driving down the highway, right, and your car phone rings. It's not really your phone that's ringing, though, right? It's your car that's ringing. It's, hooked up to your car by Bluetooth or whatever. And then you're driving down the road and you're talking to your car. The phone is handling all the logic, really, but the smart sort of computer-enabled car is actually the point of interface that I'm talking, right? And then eventually when I go ahead and park, I get off and I sort of take my phone with me, right? And it just follows me. The point of interaction seamlessly moves with me. I was talking to my car, but now it just sort of goes over here. And frankly, you guys, if you think about it, that's some pretty magic stuff. There are surprisingly few examples of that sort of seamless social exchange between devices, but frankly, as we get more and more devices into our hands, we need to start thinking about how do we design that exchange, where things can just sort of fluidly go from one to another. This idea of a migrating interface. So again, like I said, there's surprisingly few experiments along those lines in the devices that we carry now. There are few of these sort of social hardware interfaces. Very simple thing is this Scrabble game that came out a year or two ago. So here we have two iPhones sharing control over the single game on the iPad, right? And perhaps more interesting, it's like the two iPhones that you have, they're flipping their tiles on there, and then you move them around. onto the tablet itself. And there you have it, the world's most expensive board game, you guys. But frankly, the most interesting stuff is yet to come, and it might not be a terribly long wait. Corning is a glass company, right? For a long time, they were all about like Pyrex and casseroles and stuff like that. But then they figured out, how to make really hard glass, Gorilla Glass, the stuff that's on most of your phones. And they're like, hey, this whole thing with screens everywhere, this is working out really well for us. So they came up with this concept video called A Day Made of Glass. They wish, right? That's what they'd like to see. But I'm always a little skeptical of concept videos in general. They seem often a little bit rosy colored, especially for the company that's making them. But I think this is interesting. It has a sort of a very interesting concept embedded in it, so I want to show it to you.
Now, I'm not sure if you noticed, but this closet door is actually a display driven by Amy's tablet. All the intelligence that you see on this display, all these apps, they're all residing and running on Amy's tablet. This display spans the entire door. It has its own small footprint operating system and is smart enough to be aware of Amy's device. And based upon proximity and other rules, it knows what to display and in what format. To make this part of Amy's day a reality, Corning is helping to deliver large-scale edge-to-edge displays. Corning looks to partners for operating systems and apps that seamlessly scale and transfer between tablets and larger displays.
Oh, is that all? Creepy British guy who hangs out in little girls' bedrooms? All that we need is operating systems and software that seamlessly scales from here to there, right? That's not a trivial problem. And that's the kind of thing that we do have to try to solve and work on. But what's interesting is that these screens do exist in labs already, right? We do have the giant screens with just enough smarts to take over and run an interface that's driven by another smarter device. I think that again, is this interesting thing that we have software that knows so much about me, that has the apps that I already care about, that I can bring to any surface, and it will respond for me, right? And it will sort of contextually take over. This is a little bit of a ways away, obviously, and this stuff is, while it exists, is super expensive. But what we're talking about here is smart devices talking to each other and exchanging control as appropriately. Often with one core central device, though, like our phone or our tablet, running the show. And I think that the exciting thing, especially speaking as an interaction designer, is that that means that we get to design the spaces between our gadgets. Guys, this is really exciting. I mean, just mind the gap here, right? Design interactions in the space between gadgets to exchange content, to share control, to be contextually aware, to take our noses out of our screens so that the content just floats around us to the appropriate device. I mean, we tend to focus all the time on the individual interface as designers. What can we do with this one gadget? But as more and more gadgets enter our lives, the opportunity is not only about that lonely, siloed experience, but to make these smart, seamless communication between and among gadgets. I mean, we're pretty good at sort of syncing content at the web and then bringing it back down. We're not good at sort of exchanging that point of interface directly. I think we feel that a lot of times, right? So how can we mix and match sensors and inputs in exciting new ways to help us communicate with the gadgets and objects around us? As I mentioned earlier, the combination of these inputs is also really exciting. Instead of having a touch interface over there and a speech interface over here, what happens when you start putting them together? I think speech and gesture, Kinect-style natural gesture, are especially interesting and will necessarily develop together. You had to sort of wave at the device to tell it you're talking to it, or talk to it to tell it that you're waving at it. I think that those kinds of things make it more fluid. And you know what happens when you put speech and gesture together?
Expecto Patronum!
Yeah! Expecto Patronum, you guys. We're talking about spells, right? Where we're sort of like digitally, through our speech and gesture, affecting objects and interfaces at a distance. Let me show you just an example of what that looks like. This is my friend Aral Balkan. He looks a little tired here, because this is at the end of an overnight hackathon. And if you'll notice, he's got like some bottles of wine back here. He does hackathons right. He's on a yacht in Cannes. It was like a boat hackathon. So you guys have fun at your hackathon tomorrow, but he knows what he's doing. All right. So he brought to this hackathon a Kinect, a phone, a Mac Mini, and a projector. And overnight, drinking wine, he put this hack together.
So you're sitting at home on your sofa, watching television, and something interesting comes on, and you want to share it, say tweet it. So I walk up to my TV, and I just kind of wave at it so it knows I'm there. And then when something interesting comes up, I can just grab it, and boom,
What?
I grab, and boom, I put it over there. So I'm just holding it in my hand, and I'm putting it on my phone, and that's my hack.
Come on, that's pretty good, right? It turns out, as you think about it, it's not that complicated a hack. After all, he did it drunk on a boat, in a few hours. But what he did, right, is he told the Kinect, recognize this, screen capture, right? And then he can walk around like he's got the thing in his hand, right? He's just like walking around like this. And then he just touches the screen, and that touch says, release the photo. It's pretty simple, but somehow the combination is super magical. And again, it's this idea of working at a distance to move stuff from one to another naturally, instead of, kind of having to deal with Dropbox links. How can we do that stuff? How else might we do it? Well, 3 years ago, a few design students put together a video of paper prototypes for how smart devices, in this case sort of tablets and other small touchscreen devices, might interact. And so they looked at what screen-based gestures might evolve. So here's some of the things that they came up with. I thought you might find this kind of fun. It's obviously just paper prototypes, so it's a thought exercise, a little bit of daydreaming. Oh, that's cute, right? You can kind of like shake some content into another one and mix it up a little bit, right? Now, but that's super far-fetched, of course. Obviously, we can't do that stuff now, right? Well, no, actually, we can do that stuff right now, and it's available in the form of like little toys, or like the dice that we saw earlier today, right? Siftio is this set of cubes that know about each other's context, right? And they've got little accelerometers in them, so you can actually shake content and gameplay from one cube to another. The thing is controlled and runs from a computer or from a hub that they've got, and then just sort of it talks to these things by Bluetooth, I believe. So they're sort of lightweight, and they're kind of listening in on the commands. And of course, it's a lot more fun when you bring in additional cubes. They love it when you buy more cubes. But the gameplay gets more complex, particularly with things like word games, where you can have 7, 8 cubes, to play really sort of sophisticated word scramble games. But these guys know about each other. They can talk to each other. I've got a very expensive phone and a very expensive laptop. And frankly, when I put them right down next to each other, they ignore each other. Totally rude, right? Don't know that they exist, don't acknowledge each other in any way. But these guys, these children's toys, are smarter than that. It's like, and this is the kind of thing that we need to get better at. We used to be pretty good at it. Who had a Palm like 10 years ago, right? Remember how easy that was to transfer content, right? You had like a meeting or a contact, bleep. Somehow that got a lot harder. It's easy to send stuff to somebody on the other side of the planet, but not so much in the same room. This is the kind of interaction we need to design for in the gaps between devices. All right, so we have this idea of migrating interfaces, but it sort of starts to bring us this idea of passive interfaces. One of the interesting things about those Siftio cubes is that they aren't very smart. They don't hold on to lots of different apps. They just download the apps as they need it from that hub, right? And that's a real problem right now with our mobile environment. And right now, our apps and our phones and our tablets are choked with apps. We're constantly weeding them, right, to try to make some sense. We forget what's on them. There's too much. So one of the ideas is that we can sort of start to have, on demand, as we need it, software that shows up. And when we get that, when we get this devices that are smart enough to have that reflexive intelligence to say, I need to know more, to talk to each other, to share control, then they can also start doing some of that stuff on their own with these what I call passive interfaces, where we're incidental to their behavior. We're just the legs that bring them into proximity, right? So you guys are familiar, for example, with Nest, the Nest thermostat. And this is a good example of sort of this passive device. It's a thermostat. It controls the temperature in your house, but it has proximity sensors to know in your home, humidity sensor, temperature sensor, of course, Wi-Fi, an internet connection to get the weather outside. And it talks all the time to sort of apps and website. You can do remote control from anywhere to sort of adjust the temperature and environment in your home. As reporting, learns your behavior. Oh, it's 6:30. They always sort of like to change the heat. Let me do that for you. You guys, it's a thermostat. And it's loaded with all these sensors. Relatively dumb device, but wow, fully loaded and in constant communication. We're seeing more and more of these otherwise dumb devices that can be in constant communication. This is the Fitbit Flex, which is like the Nike Fuel Band or the Jawbone Up. It's this wristband that you wear and that tracks your physical activity. So it tracks your steps, and then it sort of, in real time, via Bluetooth, updates your phone or your computer when it's available. And of course, it syncs when it can, it communicates when it can. And from there, the information is available on any device you care to see it on. So again, we have this relatively dumb computer with a dumb sensor and a dumb display with just a few LED lights. But critically, it talks on its own, on our behalf, passively, to the machines around us. So we're starting to get these kind of dumb, always-on machines that can do that sort of sensor work that I was talking about earlier. So this is something that I think that we need to sort of think about a little bit. We tend to think about our devices as always getting more and more sophisticated, right? Faster CPU cores, faster and better screens and screen density. And that is, no doubt about it, part of our future. But another part that we need to sort of start getting better at is that devices are just as likely to get dumber. And that's a good thing. This is just the beginning, right? Dumb devices doing work for us, talking to the handful of smart devices that we actually interact with. And the interfaces of these dumb devices, as we've seen, can be very simple, possibly without screens at all, like the Fitbit Flex. And possibly even with sort of plain and perhaps, very small interfaces too, right? I mean, we've been hearing tons of rumors about stuff like this, where Apple and Microsoft and Samsung, everybody's supposedly working on the smart watch, like the Pebble, which is already out. How does your website or app look like on this? Well, we can probably figure something out. Even this seems easy in comparison to other stuff that's coming our way. We've gotten pretty good over the past few years with fitting our content and squeezing it and scaling it to rectangles of different size, phones and tablets and maybe watches. But then we get something like this, right? And Google Glass, whoa, didn't see that coming. How do we deal with that? How do we allow people to experience our sites and apps on such incredibly different devices? Things like the Pebble Watch, things like Google Glass, these are simply alternate windows into our phone, right? I mean, this is just something that talks to your Android phone. But it's a convenient, context-specific display of apps and data that are available on your phone, right? So Glass plugs into the phone, and it's the phone driving the logic. So we're back to that Corning vision of the world. We have a smart device driving convenient displays around us. But right now, we're badly equipped for this. Our content is a mess. It's a really hard thing to get our content into all these different screen sizes that we've got, let alone sort of some of these wacky, very imminent future displays that we've got. So I think it's really important to remember as you go forward that it's your API that's the application, and it's the content. How can you sort of organize your content so it can be flexible enough to be shown on any device? Because if we can do a better job of structuring our content and describing it, maintaining it, transporting it, building that stuff into our workflow, we can have meaningful APIs that devices grab and just get the content that they want and display it appropriately to the device. And that's creative control in this pretty complex and chaotic world that we've got. That's what I'm talking about here, is how can we juggle this growing number of gadgets, both smart and dumb, in our personal lives, as both designers and consumers. So one last stop here, and then I'll let you guys go out to your break, is if we go from passive interfaces, our last stop here is this cloud of social devices. And I'm not talking about the cloud that you see in all the airport billboards. The cloud I'm talking about is this cloud of social devices. So if you take all these trends, sensors, mirroring, remote control, migrating control, passive interfaces, and you have a set of truly social devices that are in our face when you need them and out of the way when we don't, but still doing work on our behalf. So what that means, right, is that we're doing more than building apps or websites. Those are just the container. We're building services, right? You have to think beyond the single interface, although that's what usually occupies us at any one time. Oh, we're building an app for this platform. There's a new Android tablet out. We got to design for that. Oh, over here, that's a Google Glass. We got to do that. We're going to throw all that stuff out in 2 years, right? That's what we always do. Presentation and technology deprecates. The thing that lasts is the content, right? Whole systems are what we have to build that can support lots of devices, because that's the way to prepare for this really chaotic, exciting, but overwhelming future of social devices. Now, what I've tried to do here is sort of put together some of the themes that we see now. And this is imperfect. Making these connections is hard. Steve Jobs said that you can't connect the dots looking forward, you can only connect them looking backward. Still, this stuff already exists, a lot of times already in our living rooms, and in our pockets, and in our handbags, or in labs that are coming very soon. My friend Bill Buxton, who works at Microsoft, is fond of saying that it takes about 20 years from an idea to hit the lab to hit the mainstream, which means that the stuff that's about to hit in 5 years has been sitting in a lab for 15 years. Stuff next year, it's already been around for 2 decades. The tools are all here for us to use. And so the ability to play with this stuff now, like my friend Oral did, to design for the gaps between devices, super exciting, super relevant, and we're ready to do it right now. So speaking of sort of right now, this is where we started. This is where we began. How do we prepare for where we're going? Well, push sensors, right? Sensors are the superpowers. Don't do it, just to be fancy, but think about, wow, what are the opportunities to create entirely new kinds of interactions that can move us off the screen and into the world around us? Think social, and for once I'm not talking about Facebook or Twitter, Instagram. I'm talking about social devices. How can we help devices be more friendly and more social to one another, to exchange content and control seamlessly? Think about your ecosystem. Not all of us, of course, are Google or Microsoft or Apple or Samsung. We don't have control over the ecosystem, but we can at least control our own. And by that I mean thinking about that API, thinking about the content, thinking about how can we create clean content repositories that can sort of move content appropriately to any of these devices, and frankly, devices we haven't even imagined yet. Part of that means that we're all cloud developers. No matter how mundane your application might be, the stuff's got to sort of live in the cloud. There are arguments all the time about native apps versus web apps. Super important conversations to have as the builders of these things, and the maintainers, and the people who have to pay the bills for them. But our clients don't care, our customers don't care. It's an implementation detail. All this stuff converges in the cloud now, and we just sort of have to be there since that's the linchpin of making these sort of social devices work. Your API is the application. Don't focus so much on the individual apps or websites at the exclusion of thinking about how can we develop the system that underlies that, because we're going to throw out the apps and the websites in a year or 2 or 3 at most. So how can we make systems and content that will last? Think about these new input methods that are coming around the corner. The world is about more than touch and mouse and keyboard. How can we combine them in interesting and even magical ways? And again, like Bill Buxton said, the stuff is already here. A lot of the stuff is already in your pocket. Stuff is already in your living room. Play with it. Put it to use. Amazing technology that we've already got. You guys, we have the coolest jobs in the world at one of the most exciting times in the history of technology, if not in the history of culture. And so it's like, wow, embrace this stuff. Look around. Use your imagination to connect these things in new and interesting ways. And go and make something amazing, you guys. Thanks a lot.